So let's talk about exponents, okay? First, let's talk about if you raise anything to the 0 power. So let's say I have 4 raised to the 0 power. What is that? Well, anything raised to the 0 power is 1, with one exception, okay? 0 to the 0 power is undefined. So what we can tell ourselves is this. Let's make a rule. Let's say for any non-zero number A, okay, for any non-zero number A, what that means is if I pick any A that is not 0, so any number other than 0, then A to the 0 power will always equal 1. Okay, now that's only not true if A, if A equals 0. So what we're saying is any number A raised to the 0 power will always equal 1 unless your A is 0. So that's why I have here A cannot equal 0. And so let's look at 3 real quick examples. 5 raised to the 0 power will equal 1. Okay. -2 raised to the 0 power will equal 1. All right, 1/2 raised to the 0 power will equal 1. So what you should notice is that if I take a number and I raise it to the 0 power, I get 1. The only time that's not true is 0 to the 0 power is undefined. So now let's look at some negative exponent problems. Okay, so what I'm talking about would be like 4 raised to the -2 power. Okay, now everything you've done up to this point has been a base, like 4 is your base, and that base has been raised to a positive exponent, but in this case it's raised to a negative exponent. Okay, when something's raised to a negative exponent, it's the same as, now this 4 to the -2 is understood to be over 1. Okay, so I'm going to call this the top of the fraction and this the bottom. If I take the 4 to the -2 and move it to the bottom of the fraction, it makes the exponent positive. Okay, now I didn't flip this. I took this and moved it to the bottom. When I moved it to the bottom, it made this negative exponent a positive exponent. Once I did that, there was nothing left on top. So when there's nothing left on top, there's understood to be a 1 on top. And so let's make a general rule. So for any integer n and any non-zero number a, okay, a to the -n power is the same thing as 1 over a to the +n power. Okay, that's where a does not equal 0. Okay, and the reason is I can't have 0 in a denominator. When I have 0 in a denominator, my function's undefined. And an example of that is if you type in your calculator 3 divided by 0, the calculator is going to give you an error because you cannot divide by 0. So a can't be 0. All right, now let's look at this. Let's say I have 1 over a to the -n, like that. Well, you can see the a to the -n is on bottom. If I want to make this exponent positive, I can move the a to the n, -n on top. Okay, move the a to the n on top, okay, and when I move it to the top, it makes this negative exponent a positive exponent when I moved it to the top. Now notice I didn't flip this, but then if I move this to the top, there'd be nothing on the bottom, so I can write a 1 because if there's nothing, it's understood to be a 1. So let's work through a few examples. Okay, this first example says 6.7 raised to the 0 power. Now we said anything raised to the 0 power unless it's 0 is 1. So the answer there would be 1. Let's look at this problem. Now you can see here that my exponent is negative. And this whole thing's on top, right? I mean, it's all understood to be over 1. So I'm going to take everything that's on top and move it to the bottom. And so I'd have 1 over, and all this on the bottom, negative 2. And I'm taking the negative exponent 4. When I moved it to the bottom, it made that exponent positive 4. Okay? And so now what I've got is this function right here is the same thing as this function right here. Okay? So now let's evaluate negative 2 to the 4th. And so I've got 1 over negative 2 to the 4th means negative 2 times negative 2 times negative 2 times negative 2. And if we multiply that out, we get 1 over negative 2 times negative 2 is positive 4. And negative 2 times negative 2 is positive 4. And 4 times 4 is 16. So 1 over 16 is our answer to this problem right here. Okay, so we're saying negative 2 raised to the negative 4 power is 1 over 16. So let's look at this problem. In this problem, I've got 4 times x raised to the 0 power over y to the negative 3 power. Now, first let's evaluate the x to the 0. We said anything to the 0 power was 1. And so I've got 4, and x to the 0 is 1, so I'm going to put times 1, and that's over y to the negative 3 power. Now, 4 times 1 is 4, so I have 4 over y to the negative 3 power. And now the question is, how do I get this negative 3 right here to be a positive 3? Well, it's simple. If I take everything that's in the bottom and move it to the top, it'll make that negative 3 a positive 3. And so this is the same thing as 4. And I'm going to move the y to the negative 3 on top, so it'll be y to the positive 3. And on bottom, I just have a 1, so I'm not going to write it. And so there's my answer right there. Okay, so in these 4 examples, 5, 7, 9, and 11, the instructions are in exercises 5 through 12, evaluate the expression. So let's do number 5. Right here I have negative 7 being raised to the 0 power. Negative 7 being raised to the 0 power. We said anything raised to the 0 power equals 1. Okay, so we're done with that one. The answer is 1. Let's look at number 7. 7 says 5 raised to the negative 4 power. We've got 5 raised to the negative 4 power. Well, this all is on top of the fraction, so let's move it all to the bottom in order for me to make this exponent positive. So if I move it to the bottom, I'll have 5 raised to the positive 4 power, and since there's nothing left on top, I'm going to write a 1. Now understand that the reason why the exponent went from being negative to positive was because I moved it from the top to the bottom, the whole thing. And so now we need to evaluate what 5 to the 4th is, so we'll just type that in our calculator. So 5 raised to the 4th power is 625, and so my answer is 1 over 625. And so that's the answer to number 7. Okay, now let's do number 9. On 9, I have 2 raised to the negative 4 power, and on bottom I have 4 to the 0 power. Well, that's 4 to the 0 power is 1. So on top, I'm going to write 2 to the negative 4 power, and on bottom, 4 to the 0 is 1. Now, I need this exponent to be positive, so I'm going to move it to the bottom, and so on the bottom, I'll have 2 to the positive 4. The reason the exponent went from negative to positive was because I moved it to the bottom, and now that there's nothing on top, I'm just going to write a 1. So now my calculator, I'll type 2 raised to the 4th power, and I get 16, so the answer is 1 over 16. So that's the answer to number 9. Let's do number 11. On number 11, you've got negative 3 raised to the negative 3 power on top, and on bottom you have 6 raised to the negative 2 power. Well, in order for me to make the exponent on top negative 3 positive, I need to put it on bottom. So I'll have negative 3 raised to the positive 3 power. I made this exponent go from negative to positive because I moved it to the bottom. Now on bottom, the exponent's also negative, so I'll move it to the top, and so it'll make the 6 to the negative 2 a positive 2. Okay, so now all I have to do is 6 squared, which is 36. That's the top. And on bottom, negative 3 cubed is negative 27. Okay, now we need to see if that'll reduce. So I'm going to type 36 divided by negative 27. and see if I can simplify my fraction, and I can. And so I'm going to move this up so I can get a little more space, and 36 divided by negative 27 will reduce. So we got to think of a number that will go into 36 that will also go into negative 27. Let's try 3. So 36 divided by 3 is 12. And negative 27 divided by 3 is negative 9. But I can see that both of these are still reduced as well. Let's divide 12 by 3 again, and we get 4. And let's divide negative 9 by 3 again, and we get negative 3. And so it reduces to negative 4 over 3. And that's the answer to number 11 right here.